Well, yeah, everyone, it's on the call. Thanks for coming. Uh, Today we're going to be talking a little bit about drones, imagery, and AI, and how we are implementing them into ag. My name is Sam Baker. I'm the CEO, co-founder here at FarmFlight. Presenting today with two of my team members, Michael Morris and Ellie Dernbaum. And then we also have Brian Guess and Jackson Stancil here as well. So FarmFlight is it's a little bars in the way I can't read. So FarmFlight is a comprehensive drone imaging service that coordinates flights, performs data processing, agronomic analysis, visualization, and integration. So essentially on the client end of things, it's as simple as giving us the fields, and then we take care of the rest from there. When I started the company, there were three main issues that I really heard from farmers that experimented with imagery, and that was the imagery that farmers were getting was low resolution, and if they wanted to get higher resolution imagery, they had to pay significant money, 10 to 15 bucks an acre, and even when they were getting, and even when they were paying all that money, they weren't getting that imagery on a consistent basis. If you've worked with satellite, I'm sure you're used to getting cloudy images. If you've worked with manned aircraft, I'm sure you're used to not getting them at all. And so when I started this company, we wanted to figure out how to really solve these problems. So to kind of go over how we're getting past that, Michael Morris is going to talk a little bit about the technology that we're using here.
Yeah, thanks, Sam. So I got a little bit of background in drones and UAVs, so this excites me. FarmFlight uses a vertical takeoff and landing drone. It's not like a Phantom or a Mavic, something that takes off and land vertically, but when it's flying, it has very limited time to actually be in the air. It can only carry one or two different cameras, just not very effective or efficient. And so what FarmFlight has done is we partnered up with a manufacturer here in the United States. They're located very conveniently in the Midwest. And you can see there on the left-hand side, the basic drone that we're using. You take off and land vertically, but then it flies like a fixed wing. So we capture the quick launch time, if you will, of taking it off vertically. We capture extended length of flight time, so we can fly an extended amount of time. We'll get into that in the next slide. And then when the flight is complete, we actually land vertically as well. So if you're familiar with other fixed wing drones, you have to have a very large landing area to bring those down in. They crash land on the ground. Sensors get out of calibration. If you're lucky, worst case scenario is they break. We don't have that problem, and so we're able to fly a lot more efficiently than other drones out there. The other benefit is this drone is and again, we'll get into the specifics here a little bit later, but the drone is able to carry the sensors at one time. So we're not taking a drone up, we're not flying it 2 or 3 times over the field. All of our sensors go on at the same time. And then we're flying just a standard AV pattern across the field. It is a fixed wing. It flies over the field, circles back. It's not like a manned aircraft where it's going to have to go and fly 2 or 3 miles, maybe capture another field, circle back, and hopefully capture the rest of your field. It is a dedicated pattern that we do have, the ability for that drone to fly. So it's not randomly flying around. Sam, you want to go to that next slide? So the other beauty about FarmFlight is we have essentially these hubs around the Midwest, and you can see that on the left-hand side there. This is still in development, so this isn't set in concrete by any means. But we're going to have that hub around Kansas City where if a drone has an issue, a sensor has a problem, we're going to be able to get that drone, that sensor repaired or replaced very quickly, usually within a day. And so you're not going to experience those downtimes. The other benefit to this is we're going to have teams local to our clients. Manned aircraft, they would be based in one state and they may have to fly across another state in order to go fly fields, and there's weather fronts and There's fuel that they have to worry about and land and take off, and there's a whole bunch of other things that go into that. We're not going to necessarily have that problem. We have local pilots who are trained in these drones. They understand agriculture. They understand what's needed. And so they know what they're looking for, and they know what to do when they get there. And they're not going to have to drive hundreds of miles to your field in order to capture that for you. And again, with our drone, it can fly fixed wing speed, so 40, 45 miles an hour, depending on wind, somewhere in there. And again, we can fly for 80, 90 minutes at a time. There's some things that change that a little bit, but over an hour. And so it's not like your Phantoms or Mavic, where you're only flying for 20 minutes at a time, and you got to land it back, and the sun has changed, and clouds have moved, and we don't have to worry about that so much. And again, as I already mentioned there, we have a service agreement with the manufacturer right here in the Midwest. I'm based just outside Kansas City, and so I'm familiar with this manufacturer. They're not far from me, and we're able to then make sure that they can repair, build, supply us with parts, with the new unit if need be, again, in a time-sensitive situation. Here we go. Our image quality is, and again, if you're familiar with remote sensing in agriculture, you've kind of got three different tiers. You've got satellite, which is several meters, maybe up to 10 meters. And then you have manned aircraft or aerial imagery, which is typically between 6 to 7, maybe 8 centimeters, depending on how it's being done. Some companies can get down to 3 or 4 centimeters, but the quality then starts to suffer a little bit with some blur. But anyway, what Farm Flight is able to do is capture a couple different levels of resolution, our best being the 0.7 centimeter resolution. And basically what that means is you can zoom in and see not only the leaf of the plant, but you're going to be able to see a bug on that plant. You're going to be able to notice if there's a disease starting on that plant, identify that, and be able to then make that actionable and not have to go out in the field and scout for that and understand what's going on, how much of the area is affected by that, and start making some actionable reasoning off of that and be able to correct that. Every flight, well, I shouldn't say every flight, most flights, you're going to get your basic color, which is RGB. You're going to get NIR, which is near infrared. You're going to get the crop vigor, and then some elevation data as well. We do have the capability of throwing that thermal camera on there. And here in the Midwest where I'm at, we've got a lot of pivots. We've got a lot of subsurface irrigation for tile. Thermal is a very key layer to understanding imagery. And I know when you get out west and specialty crops, again, it really goes into how much that crop is using water, if you've got leaks, if there's a block somewhere, and then able to understand that. And again, by using the other layers, we're then able to understand what's going on with that crop without even going out in the field, thanks to our image quality. And this slide just kind of duplicates what I just talked about, being able to use the different layers, stack them up, if you will, and understand, side by side, what's going on in that field. So you can have an RGB image on one side of the screen and have a vigor or an NIR, maybe a thermal on the other side, and understand those crop metrics and how one part of that plant might be better than the other part of the plant, and what's causing that, really more than just seeing that on the map and going, well, it doesn't look right, but I don't know why. You still have to go out there. We're going to offer all these different bands or different layers, if you will, and so you're able to make all those decisions while sitting at your computer, while you're in the truck on your mobile device, and able to understand what's going on.
Yep. Thank you for that, Michael. I think an important part to hit on as well is after the image collection is finished, how are we helping? And so here's kind of the general workflow that we operate on. Right, we have the image capture and direct upload from flight to the cloud. Once the imagery is collected, it's then stitched in the cloud and sent to third parties for analysis, and then also sent to the web app as well. Once all the imagery is within the web app, we can actually integrate directly into essentially every major farm management system. So say you have 4 or 5 different data inputs that you're working with, and you want it all in the same place. You don't have to have, you know, four or five different farm management systems or apps that you have to log into. We can integrate directly into your software, and you can access all of your data there. Now, I think we wanted to get into a little bit of image analysis. So, Elliot, do you want to take it away?
Sure. Yeah. Thank you there, Sam. In terms of the application of the imagery, this is really the substantive part of the conversation, right? We have analyses that work both in specialty and in commodity markets. But when we're focusing in the specialty market, one of the big players is trees and tree nuts. And what we're looking at here is a orchard in Arizona. The pink-hued block there is a pollination analysis, and the RGB, the brown one, is a tree count. The utility of the pollination analysis is huge. This is we're about a month out, more or less, from flowering for most orchards, almond orchards, right now. And once that flowering goes and initiates, just sort of timing out where to introduce bees to help pollinate is a big decision for a lot of growers. And so doing some sorts of analysis like this early in the season really helps them in terms of prioritizing the areas, the rows, the blocks, and even at the sub-block level, where a lot of bees need to be introduced in order to pollinate the rest of the field. You know, NIR, near-infrared imagery, has been used in order to verify the distribution of these pollination efforts for a while now. But what we've been able to do with drone imagery is reduce the price, increase the rapidity in terms of the processing pipeline, so that you can make more off-the-cuff decisions based on imagery that's coming back faster than it had in the past. And in terms of tree counting, the utility there, you know, is obvious at many levels of decision making, whether it be, you know, after the season and trying to decide whether or not to pull trees that are towards the latter stages of their development, and also just from the marketing decisions late season, understanding what you're expecting to yield based on the number of trees you have, based on previous yield data, and based on vegetation indices that we also include that can clue you into crop health. So especially with trees, because they are larger, because the canopy is really visible, we also don't need to fly quite as low to capture high fidelity data. And as a consequence, you know, we can drop prices down much lower, fly at higher altitudes than what is currently on the market. So we're making great strides in terms of trees. But moving on, I believe we're talking about a wheat field here. And this is in Kansas. And you know, this is a very interesting field. It's got a lot going on. It used to be 3 fields, and you know, as is often the case, it sort of all got jumbled up into one. You know, one thing to note is this was historically primarily a wheat field over the last 5 or so years in terms of the crop rotation, with some exceptions. So, you know, on the side with the vegetation index, which is the one with a lot of red showing, you start to see a little bit of the trending of the field. So, you know, the northwest area seems to be doing all right. The northeast area seems to be doing very well, where you see in the center panel stand count, and on the far right hand panel next to the data analytics, you see the nitrogen analysis. The nitrogen analysis is showing on that northeastern part of the field a very high figure in terms of nitrogen content and vegetation content there relative to the rest of the field. And then down in the main block, the southern half of the field, you see a large canal that is dug through, and then sort of a decreased stand density down north of that canal, and also a bit of a decreased nitrogen content down near that canal, except for right around the edges, actually. So what's interesting here, and sort of when we suss this out with the folks involved with this field, what they had clued us into was that the likelihood in the southern half of the field and in those affected areas was emergence issues associated with water channeling down into the canal and sort of leaching out from under those proximal areas to the canal. So, maybe next year a little bit more early watering would help sort of keep those up to speed, or some sort of application of a nutrient. In that northeastern stage of the field, what we found was, looking at the history of the fields, and because they had been combined over the years, that area that was performing very well in terms of nutrient density, that is up there in the blue section, was actually the only part of this field that was transferred this last year from a crop rotation that most recently had corn on that area. So the nutrients associated with the corn remained retained in the soil, and that really benefited the wheat grown in that area, especially relative to the other areas of the field. This field is not uncommon in its variability, and we see a lot of performance sort of like this all across the mid-plains and in the northern plains. So it serves as a good example. Moving on, we're looking at, an early season corn crop. And this is also, a pretty interesting field for a lot of reasons. The first thing that you see even on the RGB is a huge disparity in emergence across this field. Those darker patches in the north end contrast really dramatically with the lighter patches on the south end of the left-hand side of, this northern side of the field. And then that same sort of patchiness continues down into that southern section there after the elbow. And this could be for a lot of reasons. But what we really want to make sure that it isn't for sure is an issue with the planter and the seeding of this early season corn. So moving on, we did nitrogen analysis, and we also get the vegetation index there. And they seem to corroborate the same sort of pattern that we saw in the RGB, which is this dramatic differentiation between that northern half of the top end and after the elbow, that southern part. So you can see that the patterns track pretty directly. And the kicker here is the next slide, really, that shows what the stand count looks like. And the stand count has a relative uniformity. It's the only one that doesn't show such a dramatic differentiation in the pattern. And why that's interesting is because we know now that it wasn't an issue with the planning phase of this process. Instead, we know that the emergence and the development of the crop post-planning, still early in the season, was affected. And most likely because of how extensive that affected area is. It's a nutrient issue, it's a fertigation issue that really warrants the initiation of some sort of zone management techniques. And really that's what we want to promote with a lot of this imagery, especially in the commodity markets, is the very beginning, sort of the training wheels for zone management for folks that have sort of considered it in the past, but not necessarily known their pathway into it. If we can go back one slide really quickly, what you can see is such a dramatic differentiation in the imagery that you could, without necessarily having any sort of precision application equipment, calibrate your sprayer or calibrate your distribution system to emphasize those areas that are so significant in terms of relatively low emergence and low vegetation, in a way that would, especially early in the season, save a lot of crop and make up for its expenditure in terms of imagery, pretty undoubtedly. So moving forward, I think, Michael, you wanted to talk a little bit about some late season corn. Is that right?
Yeah, that's right, Elliot. And just looking at the chat section here, question is, do you think the difference in emergence was due to soil moisture in that last slide there?
Yeah, absolutely. I think that could certainly be one of the main causes. We don't have the elevation map pulled up here. I'd like to see what the elevation is, just to corroborate whether or not that's an area of higher elevation or lower elevation. We also don't have the information about the irrigation systems, nor do we have a thermal layer. But were we to fly a thermal layer on top of this, that would certainly illuminate whether or not for sure this was a soil moisture issue. That being said, we do think that it's some combination of nutrient and soil moisture. And what we're trying to express here is really that deductive process of using multiple levels of analysis to come to an agronomic conclusion without having to set foot in the field. And so that you can delegate your work a little bit more efficiently. That really is the emphasis of the utility of imagery and imagery in this capacity. So hopefully that answers the question.
Yeah, I think that was a great response. And I'll just take a moment. If anybody has questions, I know Sam mentioned it earlier, feel free to put them in the chat there. We'll try to catch those as we move along here. If not, we'll get to them at the end. So yeah, I want to talk about late season, mainly in corn. And a lot of people, and I'm going to skip kind of mid-season, and a lot of people understand the benefits of variable rating their nitrogen off of imagery and how to correctly apply your nutrients, things like that, different ways of doing that. Late season brings its own set of challenges, if you will, especially here in the Midwest. A lot of different weather patterns come through. We have crops that tend to dry down differently in different parts of the field than other parts. And this is a really good example. This is a field in Iowa. And you can see we've got waterways cutting through the field, and it's kind of a cut up field, but you can see we have dark brown areas in the field and we have light brown areas. And if you're familiar with agriculture at all, you know what this is. The lighter brown areas, of course, are those areas that didn't dry down as much. They're not as far along. And if what you don't see here is there's a road going on the south end. If you're just driving by, you're doing that 30-mile-an-hour scouting that a lot of people do nowadays, you're going to see the darkest rows along the end of the field. And you say, well, I've got a little bit of time. I'll step out on my truck. And you walk in 30, 60 feet maybe. Well, I'm out of the end rows. And yeah, it looks like it's drying down. It's pretty good. But what you don't see is the north side of that field, really kind of the north 3/4 of that field, if you will, haven't really dried down as much as the other parts. And so if you get into that field with your combines, you're calibrated, you're set up, you're ready to go. Moisture is right where you want it to be. And then the next pass, it starts jumping up. And you're like, well, it's just a fluke. It's a wet part of the field. And you start making excuses. And all of a sudden, the corn gets wetter and wetter and wetter. I had a customer a few years ago, honestly, that told me, we used imagery to start our harvest. And he said one of the reasons we did that was by using imagery, we knew where our dry down was going to be. And not only did we make harvest decisions off of that, but we also made decisions on how much propane we needed for our dryers, how much we needed for our heater in our bin. This guy was up north. And it's a really big deal. He honestly about cut himself short because he didn't realize that not all the corn was drying down. And that's very obvious right here in the vegetative index that we see a lot of areas of this field, the more north you get in the field, didn't really dry down. And so if this farmer wasn't prepared for that, it would be really kind of a shock, not only to the machine, because he would have to reset the machine to handle that higher moisture corn, but he would also need to then set up his bins a little different, maybe get the dryer set up a little different, maybe get a few more trucks set up, things of that nature. What this also paints a picture for is our corn stover. If you're baling the corn stalks, what are the condition of those stalks going to be in? If you're going to come in and graze that, what kind of feed value am I going to have? Am I going to start running into some disease issues here that's, going to have an adverse effect after I turn my animals loose on this? Even, if you're doing a winter crop after corn, such as a cover crop or a wheat, how much residue am I going to have in this field in certain areas? And, not so much what's the moisture content, obviously, but how is that residue going to break up over time and degrade? Do I need to put something in the drill to help break that up a little bit faster? Or am I okay to just go forward with my normal plan? The next slide, we'll go into the elevation side of it. And again, you can kind of see how all the water funnels into that waterway. It's very easy to understand that. And so as you start looking at this map, your eyes immediately go, okay, well, obviously the water runs downhill. But what also runs downhill are nutrients, whether it be nitrogen or other. It's going to have an adverse effect on that corn in this situation. And so if you go back and forth, and we're not going to do it because I don't want to make people dizzy, but if you look at the crop changing over the course of the season, even right into dry down time, you'll see that the lower the elevation, it actually corresponds with how this elevation data sits with how that corn dried down. You can also start making some management decisions on nitrogen, again, in that winter crop. How much nitrogen am I going to need in these areas? Where is it going to be the most beneficial? Or where do I just need to really kind of pull back and reevaluate, maybe not putting this field in wheat? Maybe I've got a drainage issue that I need to take care of here. This elevation map's going to be able to take care of that, as well as answer questions throughout the growing season on how runoff may be occurring in that field. Elliot, this is a soybean field that you're familiar with. You want to answer some questions about this and talk about it a little bit?
Sure, yeah. This is also late in the season, and it's a soybean field. And one thing I find really interesting right off the bat with this field is that at that unzoomed view, the RGB image that we're looking at is relatively uniform. You do see a few lines and stuff there, but in general, the canopy seems to be pretty consistent, just in the RGB, obviously. And in the zoom view, you can see some patches, and I think that, that's a testament to the resolution of the imagery more than anything. You're always going to find some patches the harder you look, but in general, the variability of the corn on the RGB would initially seem pretty encouraging to folks. If you look at the elevation map as well, there isn't anything here that sort of indicates to me that you're going to see any sort of large gradation of vegetation health. But I am preluding a little bit because when we do look at the vegetation index, it shows a different story. And I was just flipping back and forth between these images, the elevation map, trying to see why we saw such a dramatic gradation in terms of the vegetation density, and how it might have occurred until I asked Sam, who had asked the grower what was going on with this field, and they told us that it was two different varieties of soybeans. So you can be led astray if you don't have the right information ahead of time, or if you're not using the data in conjunction with field knowledge, with planting data, with the spray data as well. But this is again a testament to the differentiation of the capacity of differentiation of the imagery more than anything, truly. These crops are relatively indiscernible from that bird's eye view in the RGB. The elevation gives no indication of any issues. And truthfully, we aren't absolutely sure that there are many issues on the right-hand side of this field, the red side of this field, just based on this vegetation index alone. What we know is that it's vastly different from the left-hand side of this field, where there's a lot more green matter. That sort of thing happens all the time, where one indice tells a very different story from the rest of the indices. And in fact, we usually see that as a positive, because it means that we can deduce through a series of inferences and understanding the field history what exactly is going on in each field. And really, that's the point of imagery. So, I think this is a good example of that. But I guess moving forward, we're going to talk to Brian Guess of Marone Bio, who is using the imagery in all over the country. Apparently, that Marone Bio is doing business. But I think we're going to take a look at some slides of some lettuce in the Southwest too. So, take it away, Brian.
Excellent. Thank you, Elliot. Yeah, so I'm the territory sales manager for Marone Bio. And for you, those of you that aren't familiar with Marone Bio, we are a chemical manufacturer specialized in biological and certified organic fungicides, insecticides, and plant health products. I'm just going to talk to you guys briefly how we are using FarmFlight's technology in the process of showing efficacy data to growers, and then also aiding me in selling our products into new markets. So moving on to the next slide, this is just a quick little snapshot of our product portfolio. You can see we have some insecticides, fungicides, and a plant health product, Pace Setter, which would be more relevant to the group here. This is targeting the row crop market, corn, soybean, cotton, alfalfa. It takes one of our active ingredients from Regalia, a plant extract, and puts it into this product. And then on the next slide, this is the trial that we used FarmFlight's technology for, just to lay the groundwork. It was out in Yuma, Arizona on head lettuce, otherwise CRISPR lettuce or iceberg lettuce is more the common term in the store. So Fusarium oxysporum is a soil-borne pathogen that we're trying to control with one of our products. And it attacks the roots of the lettuce, deteriorates those roots internally, and it inhibits the plant from transferring nutrients and water up to the leaves. And you can see the far right picture is what happens when the infection becomes prevalent. And you can see it from a picture easily. And that's the root on the left-hand side. So what we did on the next slide, we treated one portion of the field with our Stargus product, 2 quarts an acre. And then on the picture on the left-hand side, that is the grower standard. So typically when I'm selling a product or trying to prove efficacy to a new grower, I'll go out there, I'll put our product up against their standard, and then I can take pictures from the ground, I can collect yield data, we can walk the field together, and you can see this one is a prevalent picture of treated versus untreated. But what I've now been able to do with FarmFlight's technology is incorporate the near infrared imagery, and starting on the picture on the right-hand side, that is the treated field with Stargus, and the picture on the left is the untreated field. You can see the top left corner of that block was where I took the picture from the ground, and you can see those patches. That is where the infection of Fusarium killed those plants, reducing the yield and ultimately lowering the return for investment. Typically, this is a very drastic case, and there's some other subtle differences on some other trials. And by using this near infrared, I can really get a bird's eye view and show the grower the value that my product's bringing to the table. And then to take it one step further, we are also able to run stand counts of the treated and untreated. You can see Stargus is on the right-hand side, and one more click and it should show a little orange circle or red circle. There we go. So it has the average plant count per acre. You can see we have an increased plant count per acre compared to the grower standard on the left-hand side. So by using this data, I can really put some numbers behind my claims on our products, and then also ultimately return a better dollar to the grower. And that concludes kind of how we're using it on a chemical efficacy standpoint. Here's my contact information if you have any questions about our products. Sam and Elliot, Michael, thank you for letting me share.
Yeah, thank you very much. I think that's fascinating application of the imagery, and also, very effective demonstration of the utility of your products there. So moving on, I think we're going to talk to Jackson or are we going to talk a little bit about some of the analyses we did?
So, really want to quickly, sorry, I switched up the slides on you, Elliot.
Oh, you're good.
Really want to quickly talk about those analytics that Brian just referenced there. Here's the full slate of third-party analyses that we're offering. They're accessible in shape files and also quantified data. So not only are we highlighting areas of distinction and differentiation, but we're actually quantifying different data points in the field by severity and in acreage format and in percentage format as well. All this data is fully integratable with, as I said, almost every major farm management system. And it's accessible on mobile, tablet, and desktop as well. So now I'd like to introduce Jackson Stancil. He's doing some research with the University of Nebraska on sensor-based fertigation. So yeah, Jackson, if you want to take it from there.
Sure thing. Appreciate it, Sam. So as Sam mentioned, I'm Jackson Stancil. I'm a master's student in agricultural and biological systems engineering at the University of Nebraska-Lincoln. And the picture over here on the right is me kind of working on our sensor-based fertigation project. We've kind of been doing our own drone flying up to this point. And actually, that drone right there is one that I crashed last summer because of those really large landing spaces that Michael was referencing earlier that luckily with vertical takeoff you get to avoid. So I work with a team of researchers in the agronomy and horticulture department as well as the biosystems engineering department to develop our sensor-based fertigation method. And so we'll kind of get into talking about the motivation for that method now if we can move to the next slide. And so really what our goal is with sensor-based fertigation management is to maximize nitrogen use efficiency through optimal fertigation management. And the way that we're trying to do that is using data from multispectral imagery to make fertigation application timing decisions. So really we just want growers to put their fertigation applications out there when the crop actually needs them and not when it doesn't, ultimately conserving the number of applications that are made during a year if possible. And so the motivation behind this is number one, environmental benefits, and number two, profit benefits for the grower, because the less you can spend on nitrogen, the really the better it is for your bottom line. And for any of those folks who are out there, any participants we have in Nebraska, other states in the Midwest, you realize that regulations are starting to become a much bigger deal in agriculture. And so being able to use your nitrogen efficiently without affecting your bottom line is going to be a really, really key thing in the coming years. So lastly, just to talk about how we're validating this method, we are testing this through field trials on commercial scale farms, and all the stars in the picture on the right kind of show where we've had commercial trials or commercial scale farm trials over the past 2 years. So getting into the method a little bit more, how does sensor-based fertigation work? Well, the way that we're doing this is we start with pre-season data collection and analysis. And so what we're going out there and collecting is soil electrical conductivity data, multi-year yield history, as many years as we can get from growers out there. We're getting elevation and slope data, typically using LiDAR, but obviously farm flight, is enabling an elevation layer as well with what they're doing. And so that could end up being a really good high resolution source of that data. We're also getting irrigation system specific parameters, pivot length, pivot center, flow rate, all these sorts of important parameters, as well as fertigation system specific parameters, especially if you have a variable rate fertigation pump. So after we get all that data, what we do with it is we turn it into essentially a zone analysis for the field that helps us to figure out where we're going to put our indicator blocks, our physical indicators out there in the field to help us make decisions throughout the growing season. So early in the growing season, even prior to the growing season, what we'll actually do is put in these indicator blocks with some sort of variable rate application equipment. We've even used the pivot to do this. And then after we get that application done, we get into our weekly cycle. And that weekly cycle consists of collecting imagery, which an example image is shown up here in the top right corner. We go to processing that imagery, which again, this processed imagery it requires stitching, like what Elliot and Sam referenced earlier. We analyze that imagery using our kind of analysis algorithm that we've created. And then we generate fertigation decisions for every managed field subregion out there in that field or for the whole field itself. And then we generate a fertigation prescription that can be sent directly to an interface for a pump or directly to that pump out in the field. And then we finally make that fertigation application. And we repeat this every week until we get to some predetermined date that is comfortable for the grower prior to physiological maturity of that crop. And so overall, that's how this process works. Now, if we'll move to the next slide, we'll take a deeper look at the analytics layer. And so as you can see out here, we have management zones that are kind of out here in each one of these different managed sectors of the field. And what our analytics are really doing is they're putting a nitrogen sufficiency indicator and index value on each one of these managed areas. And so we're able to distinguish for each one of these sectors that are out there in the field whether or not they're sufficient for nitrogen. Now, what this data set ends up becoming is kind of the groundwork for applying machine learning algorithms and applying artificial intelligence to help us better tune the parameters that are associated with our algorithm that we are using to say whether or not we need to make fertigation applications. And so this is kind of the higher level. Obviously, we'd like to go much higher resolution, but for any of you know that pivots right now are really only capable of applying the same rate across the entire length of it. And so that's why we're operating here now, but this really enables us to go much higher resolution in the future. So what are we really getting out of these tests so far? So this data right here on the right kind of shows the difference between our treatments and the grower treatments out there in our commercial scale field trials. And so what we're looking at is a risk averse and a risk tolerant approach. The risk averse has one set of parameters and thresholds that we use in our analytics, and the risk tolerant has another set. We also see last 60 and full season as different treatment names. So basically what that's saying is, are we using sensor-based fertigation for only the last 60 pounds of applied nitrogen, or are we using it for the entire season? Okay. And so what we see in these results right here is that so far the risk averse approach applied for the last 60 pounds of nitrogen has actually led to marginal net return, so profit increases for versus typical grower management, and it's also led to efficiency increases versus typical grower management. All three of these have led to efficiency increases versus typical grower management, and that's consistent with what we've seen. So 94% of our site and treatment combinations have been more efficient than standard grower management. 53% of them have been more profitable than standard grower management. Now, what's probably concerning most of you is you see this number, this negative $12 per acre that we're losing with this risk-averse full season. Well, I'm going to show you the data that comes out if you remove a single rep from a single site that we had this year. And so, Sam, you can press that now. So if you remove that one single rep, and we put 4 reps in every field. If you remove that one single rep, what you actually see is that both our risk averse and for both the full season and the last 60 pounds of applied nitrogen are actually more profitable than the grower's standard management on average. And that actually bumps us to 65% of our site and treatment combinations being more profitable than our standard grower management, which is a pretty good result considering we're also saving a lot of nitrogen. So moving forward and kind of talking about some of the challenges with this method. Number one, the execution time of the cyclical process is pretty prohibitive, especially if you execute it manually. Number two, image quality can be an issue. Number three, image transfer, so getting those images from the field to the computer and back out, the analytics back out to the field, it's another huge challenge. Image stitching and turnaround time is another thing that we've run into. And finally, fine-tuning our parameter values is a challenge for us, but we're working through that. And so we are finding some solutions to these challenges. So on the image side, what we're trying to do is work with imagery providers that really understand what the priorities are for this method. So our priorities are timeliness, quality, and specifications. And that's why I'm kind of speaking today as we've started working with FarmFlight. We're going to collaborate with them on some of our beta sites this year because they understand how important it is to get timely imagery, to get high quality imagery that's absent of any impacts of clouds, wind, stuff like that. And they also understand what our specifications are. They know, what bands we need to have in order to execute this method and what sort of metadata we need to have in order to get things done. So those are important things on the imagery side. We're also trying to minimize any impact of those kind of quality issues, the weather, with how we've designed our method. On the process side, what we're doing is we're automating this entire process with software, and we're working with growers and consultants to ensure usability of both the method and the software. And then finally, we're looking at some high resolution research on parameter tuning. So really looking at, how do we make these thresholds very specific to different growing environments to create the best efficacy out there on the farm. So finally, just looking forward to what we're going to continue to do. This screenshot shown over here on the left is a picture of our prototype Enzyme fertigation management system software. This is a software that I've been developing for my thesis. We are going to be using in beta this summer. And basically what this is going to allow people to do is consultants and growers can basically log into the system, plug in imagery from a source like FarmFlight, analyze it, and get fertigation decisions and prescriptions generated for them that they can use right there on their farm. We're getting the IP protected on this, so we're currently in the middle of patent application for all this technology and conceptualization. And then finally, we're exploring commercial opportunities to bring this to scale, because quite frankly, if you do this publicly through the university, it's really hard to maintain the level of scale that you need in order to actually allow people to benefit from this. So we are exploring those commercial opportunities and hope to make it available to people soon.
Great. Thank you for that, Jackson. Really cool stuff. We're really excited to be on the front of this research. So kind of close out this presentation, wanted to go over some updates, some things that we're working on. We're developing some new software, developing integrations with third-party companies, researchers like Jackson. We're improving our pipelines to increase the effectiveness of the imagery. And we're also releasing a new Acres for Education program. Some of the software updates include a complete redesign of our UI for easy access. With that will come new in-field scouting features. One of those is a new feature that will allow you to walk into the field, take a picture on your phone, upload that to our app, and have that picture actually geotagged and overlaid on top of your map. So you can communicate throughout your organization seamlessly. We're going to be improving the processing speeds of our pipelines. We're going to be creating customizable notifications. So if field health drops below a certain level, if there are irrigation issues, if there are any kind of nutrient issues, you'll get either an email or a text notification. And we're also working on bringing in soil map overlays and bringing in different data points to our app, so you don't have to switch in between different management systems. And yeah, the Acres for Education program, to just briefly mention, is the way that we're sourcing our pilots, and it's something I'm really excited for. But essentially, for every 5,000 acres that we get signed up, we're actually going to be sourcing our pilots from nonprofits, helping them get their education through a tuition reimbursement program, helping them get their FAA 107 certification, getting them an introduction to technology and software, and then also providing them with the opportunity to advance within the organization. And I'm excited for launching this program, because I think it's a great way to give back as we're growing, and also source great pilots that can get the job done on time. Now, yeah, I'd like to open it up for questions. If anybody has anything that they'd like to say, now's the time. Maybe, hold on. I think
yeah, we've got another. Yeah, we got another question, and the ultimate question, my favorite question.
What is the price of the software?
Price?
It's $3.99. It's $0. We don't charge on software.
And also, what states are we currently operating in? Both fantastic questions, very straight and to the point. I think we can speak to these very directly. In terms of where we're going to be doing business, I think year one, we're focusing on the mid-plains, the Southwest, and in tree crops in California. We have a business model that does not eliminate the potential for different geographies insofar as we can accrue a certain amount of acreage. A minimum acreage to get started in a geography where we're not doing any business whatsoever is roughly 5,000 acres. That being said, our target in these geographies, in the Southwest and in the mid-plains in particular, has been because we feel we can provide the best services there in this first year and the highest quality services. So what that means in the mid-plains is, a lot of what Jackson and Michael had gone over earlier in this presentation in terms of really trying to push the new frontiers in terms of integrating data into decision-making in season in the Midwest. And then in the Southwest, a lot of the challenges that we face there are primarily focused on irrigation, the efficiency of water usage, the distribution of water usage, and all of the different sorts of challenges that we face when growing vegetables, melons, and then tree crops as well. They're two very different sort of sides of the agricultural spectrum, but they're unified in the sense that they both benefit very directly from imagery as a form of analysis in terms of crop health and then infrastructure. And then the price is always going to be very straightforward. What we can say about the price is that it does differentiate in the different markets. It's always going to be sub $2. And depending on the different analyses that we put on there, you'll have a little bit of add-ons, but at a base level, the imagery should outright in terms of getting a vegetation index, getting a high quality, high resolution, sub-centimeter resolution image. That's always going to be either half or a third less expensive than what has been out there consistently in the market, which has been something between $3 and $5. Our goal is to show growers that this is the beginning of zone management and the beginning of sort of a new data-informed era in terms of farming, and imagery is a really good step in that direction. The hesitancy that we've seen from growers in terms of getting involved has been almost entirely due to price and not interest. There is huge interest in drones and in precision farming, but the price has always been prohibitive. And so that is a huge focus of ours, is dropping the price as much as possible. I see another question here that talks about whether or not we can do the software with your own drone, or if you need to hire the services. You are in Alabama. Potentially we can work in Alabama. Obviously, we don't want to close ourselves off to different options. As far as I understand, and Sam, you can speak to this probably better than I can, we're trying to use our own payloads for image capture. That being said, if you have unique circumstances, please reach out to us. We're always capable and able to try and provide a service that is tailored to each person's needs. So
Yeah, I think you're right on there. We can do the stitching with your equipment, or image processing with your equipment. That's not a problem. With that said, the equipment that we are using is much higher quality than what you're going to get with a commercial grade drone. The VTOLs that we are using, they're custom made specifically for specifically for us and for mapping. So we can equip those drones with any piece of equipment that we want, or any sensor that we want. So we have the power to get resolution as high as 0.7 centimeters per pixel, and then we also have the power or the ability to get all the different imagery bands, thermal, NDV, or thermal, NIR, red edge, RGB, DSM layers. That's you typically can't get that with off-the-shelf drones. But yeah, great question. Do we have any more questions here?
Hey, if there's no questions, I want to say first and foremost, thank you for everybody that attended. I want to say thank you to Brian Guest and Jackson Stancil, our guests here, and our partners. We really appreciate you guys demonstrating your methods for using this imagery. And we appreciate everybody that has interest and supports us. Hopefully we can continue to receive y'all's support and work with y'all to improve this, because we are sort of on the dawning of this company, and also in this effort to really integrate data into agriculture in the most creative ways possible towards a future that we're all trying to work for. So in the meantime, get in touch with us and look out for more stuff coming out. Jackson there very intelligently put his email at the bottom. If you have questions about some of the really excellent research that he's up to, please don't hesitate to reach out to him, reach out to us for any reason. And reach out to Michael if you are anywhere in the Mid-Plains, because he is lonely and he wants to talk to people.
I'm not sure I go that far. You haven't seen my calendar lately, have you?
Yeah. Well, he's got a very full calendar and he's got kids, so please hold it into working hours. But yeah, reach out to us, talk to us. We want to get your guys' input as much as possible. So thanks again, everybody.
Yeah, everyone, thanks for coming. Looking forward to connecting with everyone after this.